Good day, this is DCIT 25 Data Structures and Algorithm. I came from DSIT 2A and this is my midterm examination. And lastly, I am Ive Gutierrez Badajoz. So today we're going to tackle about what is Q or Q. And we will going to have some example afterwards of this video. So Q is an abstract data structure somewhat similar to stocks. Unlike stocks, a queue is an often open at both its ends. One end is always used to insert data, which is NQ, and the other is used to remove data, which is the Q. Q follows first in, first out methodology. The data items stored first will be accessed first. So basically, the first thing that we need to know is the Q if it's used to has a removing and inserting according to FIFO and LILO, which is first in, first out, and last in, last out. So if we were going to look at Q in the real world, example of Q can be a single lane one-way road where the vehicle enters first and exits first. More real world examples can be seen as queues at a ticket windows and bus stops. So here's the example of Q. It is given by our professor, and we have this given of data elements which are 11 and 20, and array contain of index which are those 0, 1, 2, 3, and the max array size is 4. In the right side, we have this front is equals to 0, rear is equals to 1, and size is equals to 2. So front it is also called as head, and rear is also called as tail. So by doing this Q, we will have some operations, and I've come up with these operations by myself. So size and Q3, the Q is empty, and Q15 first, and Q1 and lastly is full. So first operation is size. The size, we simply have to return the number of size that is present in the Q. By doing that, we will going to look at the size or the value of size in the array, and here's the array, and it has contained of index and data elements, and we have this front is equals to 0, rear is equals to 1, and size is equals to 2. So unfortunately we have some limitation in my presentation, so pardon me. And today if we will just going to look at the size, we will going to look at the value of size in the in this array or in this Q. So the size is equals to 2, so we will going to box it. We will going to box it. Close it to the box for us to be able to know the size of the Q. So next operation, if the Q is full, so by doing that, we will going to use max size is equals to rear plus 1. So max size is 4 and is equals to 1. 1 plus 1, which rear is 1. So 1 plus 1 is equals to 2. So basically, it is not full. So our Q is not full. So we will going to proceed at step 3. We will going to skip step 2. So increment rear pointer. We will going to increment rear pointer. So we will going to proceed to step 4. Rear is equals to rear plus 1. So our rare here is 1. So rare plus 1, 1 plus 1 is equals to 2. So, and in Q, if the rare is increasing, the value of size is also going to increase. So here, as the rare increase, size will increase also. So our present size here is 2. So we will going to add 1. It is now 3. So NQ. So add element at index 2 the element 3. So after that, we will going to proceed at step 5, which returns success. The Q. Here we will going to remove some data elements. So here in the queue, it is used for deletion or removal of the element into the queue, and it will take place at the front of the queue. So we will going to follow some steps also as we follow steps in NQ. So step 1, size. We will going to check if the queue is empty by finding the value of, or check the value of size, which is size is equals to 0, and our size here is 3, and 3 is equals to 0. It is full, so we will going to proceed at step 3 and skip step 2. So our increment front pointer here is at the index 0, and we will going to we will going to proceed at step 4, which has a front is equals to 4. Front plus 1 is equals to, our front here is 0, so 0 plus 1 is equals to 1. So we will be increasing the value of front. So our front here is 1, so it has new location now. So, and our size here is 2, and we will going to proceed at step 5, return success. So our next operation here is empty. So we have this array here, this queue here, and also by using this empty operation, we will going to check if the queue is empty. So by checking the value of size, so size is equals to 0. So our size here is equals to 2. So 2 is equals to 0. It is returned to false. So it will return at Boolean value, which is false. So the next operation is NQ15. NQ15, we will going to add again, or we will going to insert elements or data elements. So also we will going to use we will going to follow some steps for us to be able to insert data elements. So NQ15, step 1, we will going to check if the queue is full. So we will going to use this max size is equals to rare plus 1. So we will going to look at our rare, and our max size is 4. 4 is equals to 2 plus 1. So 4 is equals to 3. It is false. So we will going to skip step 2 and proceed to step 3, which increment rare pointer. we will going to proceed at step 4. Rare is equals to rare plus 1. So our rare here is 2. So 2 plus 1 is equals to 3. So our rare is full, and if we will going to increase the value of rare, we will going also to increase the value of size. So size 2 plus 1 is equals to 3. Then proceed to step 5, return success. We add the 15 at the index 3 where the rare is pointing. So our operation today is first, we will going to look if our front is where it is pointing. So our front here is 1, rare is 3, size is 3. So our front here is pointing at index 1. So basically, our first is the index 1, which have the data elements is 20. So the next operation is NQ. And Q1, we will going to insert again 1. And here we have the front, our front is equals to 1, rare is equals to 3, size is equals to 3. So step 1, we will going to check if the Q is full by doing max size is equals to rare plus 1. So 4 is equals to 3. Since our rare here is 3, so 3 plus 1 is 4. So 4 is equals to 4. So we will going to return it in the boolean value, which is true, because they are equal. So it means that the array or the queue is full. So step 2, exit. We will going to exit, or it is now error. So the last one operation that we are going to use is full. Now is it we will going to check if the size is the size of Q, or the Q is now full. Max size is equals to rare plus 1. So 4, our max size here is 4, is equals to 3. So since our rare is 3, so 3 plus 1 is equals to 4. So it is now full, or it is returning at a boolean value which is true. So that means the Q is full. So that's all. Thank you. So this is all about the Q. The basic Q, it is inserting and removing data elements according to FI, FO, and LI, LO. So that's all. Thank you. I hope you learned something new today. God bless.